بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الديناميكا اسمه الشغل. الشغل طبعا مفروض إن هو بيتطلب قوة ومسافة، فإذا احتاجنا إن احنا ننقل جسم من مكان إلى مكان فبنحتاج قوة وبنحتاج مسافة. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in dynamic. It's called the work. What is the meaning of the work? Dear student, look at introduction about the work. The work done by constant force F in moving the particle from an initial position to final position denoted by work W is defined as the scalar product of force vector times displacement vector. Remember, dear student, W or the work is defined as the scalar product of two vectors. The first is called force vector times the second is called displacement vector. Look at, dear student, if we have this force inclines the horizontal by angle theta, what is the work which we need it to move a body from the initial position A to final position B? This W equals vector F scalar product vector S. What is the vector F? Represent vector of the force or force vector. S vector represent displacement vector. Then the work done which we need to move a body from A to B is called W equals F vector scalar product S vector. And by using, if the force inclines the horizontal by angle theta, F scalar S equals F times S cosine theta, which is theta, the angle between the force vector and AB ray or displacement. Units of the work. What is the units of the work? Remember, dear student, units of work equals unit of the force times unit of distance. Why? Because the equation or the previous equation, work equals force scalar product distance. Then unit of the work equals unit of force times unit of the distance. What is the distance? Urge equals 9 centimeter. The work, its unit urge. What is the urge? Is the 9. What is the 9? Unit of the force. Dot centimeter. What is the centimeter? Unit of the displacement. Then urge, unit of the work, equals 9 times centimeter. Joule. Joule is unit of the work, equals Newton dot meter. What is the relation between joule and urge? Is relation between Newton times meter and 9 times centimeter. Then what is the joule? Equals 10 power 7 urge, or 1 urge 10 power negative 7 joule. Then the relation between joule and urge joule equals 10 power 7 air. Rule: the work done in displacing a body several displacement is equal to sum of the work done in each of the individual displacements. Now, if a body is displaced from A to B, then to C, then look at the opposite figure. The body moves from A to B, then from B to C. A body is displacement from A to B, then to C. What it deduce? The work done equals sum of two works, W1 from A to B plus W2 from B to C. Example: dear student, now we are translate two important examples. Particle moved along straight line under the action of the force F vector equals 6I vector negative G vector from the point A, its coordinate 2, 1, to the point B, its coordinate 4, 5. What is required? Calculate the work done by this force. Solution: dear student, at the first we find displacement S equal vector AB, B vector minus A vector, or point B minus point A, equals 4, 5 coordinate minus coordinate of 2, 1. Answer is 2, 4. Then is displacement vector. The work done equals force vector scalar product displacement vector. By using scalar product 6, negative 1, the first order pair, scalar 2, 4, second order pair, equals 6 times 2 plus negative 1 times 4 equals 8 work units. Now we are translate to another example. Dear student, if we have two forces F1, 2I minus 3J, and second force F2 vector 5I plus J act on a body moving on a straight from the point A, its coordinate 2, 1, and B, its coordinate 3, 0 respectively. Find the resultant of the work done. Find the resultant of the work done. Solution: dear student, we have resultant of the two forces. We have two forces, F1 and F2. At the first, find the resultant of the two forces equals sum of the two forces, 2I minus 3J plus 5I plus J. Then the force is 7I negative 2J. This resultant of the two forces, 7I minus 2J. After that, we find displacement S equals AB vector equals B vector minus A vector. 3, 0, the first order pair, minus 2, 1, second order pair. Answer is 1, negative 1. After that, dear student, we know that work equals scalar product of vector F and vector S. Vector F is resultant of the two forces. S is displacement or AB vector. Then we find scalar product 7, negative 2, dot 1, negative 1. 7 times 1 plus negative 2 times negative 1 equals 9 work units. Dear student, in this example, we know that if we have two forces and two forces act on the body and moved it from point A to point B, what is the work done? As a first, we find resultant of the two forces by adding of the two forces. After that, we know that displacement equals AB vector or B minus A vector. Then we know that the work done equals vector F scalar product of vector displacement. After that, we find the work done of the body from point A to point B. Remember, dear student, unit of the work equals unit of the force dot unit of displacement. Dear student, we are translate to another example. We know that W1 equal F1 dot S. W1 equals 2 negative 3, the first order pair, dot 1 negative 1. Answer is 2 plus 3 equals 5. What is the W2? F2 dot S. By the same method, we find scalar product of vector F2 and vector displacement. F1, F2, its order pair 5, 1, displacement S, its vector or its coordinate 1, negative 1. Then 5 times 1 plus negative 1 equals 4. We have two works. Then we find the work done by or resultant work by adding of two works. Then work equals W1 plus W2. Answer is 9 work units. Then the resultant of the work is 9 work units. Another example, if we have a force F equals 2I plus 3J act on particle so that its position vector at any instant t is given by the relation R equals bracket contains 3t squared plus 7 I vector plus bracket contains 3t plus 2 j vector, where F is measured in Newton. Distance in meter, time in second. Calculate the work done by the force F from t equals 1 to t equal 3 seconds. Solution. Dear student, at the first we find displacement equal R1 minus R naught. What is R? 3t squared plus 7 in vector I plus t plus 2 in vector j by using R1 and R0 or R0 by putting t equals 0, then R equal 7I plus 2G. Then displacement becomes 3t squared plus 7 in vector I plus t plus 2 in vector j minus 7I minus 2G by using like terms 3t squared in I plus t in j vector. Since the work done equals the force vector scalar product S vector, by using scalar product 2, 3, the first order pair, scalar second order pair 3t squared and t equals 6t squared plus 3t. This is work at t equals 1 by substitution about t equals 1, then the first work or work 1 equals 6 plus 3 equals 9 joule. By using work 2, by using 6 times 3 power 2 plus 3 times 3 equals 63 joule. Then T1 from T1 at T1 equals 1 to T1 T2 equals 3, then the work equal W2 plus W1 by using substitution equal 54 joule. Another example. A force F equals 3I plus 2J act vertical so that its position vector at instant t is given by r equals t squared plus 1 inside bracket I vector plus t minus 4 inside bracket j vector, where I and j vector are two perpendicular unit vectors. The norm of F measured in Newton and distance in meter and t in second. What is the required? Calculate the work done by the force from 1 to t equal 3. Solution. By the same method, S equals r minus r naught, t squared plus 1 in vector I plus t minus 4 in vector j minus bracket contains I plus 4j. By using like terms, then displacement becomes t squared I plus tj. The work equals force vector scalar product S vector. Then the first is ordered pairs T2, scalar product t squared t equals 3t squared plus 2t. This is the work done. At t equals 1, by substitution t equals 1, the work done equals 5 joule. 3 times 1 power 2 plus 2 times 1 equals 3 plus 2 equals 5 joule. This is W1. What is the W2? At t equals 3, by using t equals 3, then W2 equal 33 joule. After that, the work done equal W2 minus W1 equal 33 minus 5 equals 28 joule. Another example. The displacement vector of particle of mass 50 gram is given as function in time t by relation S equals 5t minus t squared inside bracket c vector, where c is constant unit vector. S is measured in centimeter and time in second. Note that particle started its motion at t equals 0. What is required? Find the force vector acting on the particle and the work done by this force during the first 5 seconds of motion. What is the required again? What is the force vector acting on the particle and the work done by this force during the first 5 seconds of motion? Look at the solution. Dear student, the relation is S equal 5t minus t squared inside bracket c vector. What is the velocity? Differentiation of displacement respect to the time t. We know derivative of S respect to the time t, ds over dt equal 5 minus 2t inside bracket multiply c vector. After that, acceleration equals what? dv over dt. Derivative of velocity respect to time t equals negative 2 c vector. Know that the force equals ma. What is the m is mass. What is the a is acceleration. By using F equals 50 times negative 2c equals negative 100c. This is force which we need. It equals 50 times negative 2 equal negative 100 c vector. So work equal F scalar product S. What you mean? What is the F? Negative 100. Scalar product, the S vector is 5t minus t squared inside bracket c vector. Then is equals negative 500t plus 100t squared. As a t5, by using t equals 5, then w equals negative 500 times 5 plus 100 plus times 5 squared. Remember, in this case, the work is equal 0. Why? because negative 500 times 5 equals negative 2500 and plus 2500 answer is equals 0. Another example. Particle moves along straight line under the action of constant force acting in the direction of motion of magnitude 40 Newton. If the displacement vector of the particle is given by the relation S vector equals bracket contains third t power 3 plus 4t inside bracket C vector, where C is ionic vector parallel to straight line, S is measured in meter and T in second. What is required? Number 1, find the vector of initial velocity of this particle. Remember, the first required is find the vector of initial velocity. Vector of initial velocity. What do you mean? We have displacement x and student. We derivative displacement respect to time t to find the initial velocity of this particle. The second required, what is the vector of acceleration of motion after 5 seconds? What do you mean? Acceleration vector is derivative of the velocity respect to time t. After that, we substitution about t equals 5, we find the acceleration of the vector of motion. Number 3, what is the work done by this force measured in joule within 3 seconds from beginning motion? Remember, dear student, we have 3 solutions. The first one, if we have displacement equal third t power 3 plus 4t, this relation between displacement and time t. So first required the initial velocity, then we find derivative of s respect to time t. ds over dt equals v or velocity. The initial velocity ds over dt by using derivative, then v vector becomes t squared plus 4 in vector c. After that, for c, when t equals 0, then acceleration dv over dt equals to tc. We derivative velocity respect to time t, then acceleration vector equals to tc. Then when t equals 5 seconds, by using substitution, then acceleration in this case equals 2 times 5 equals 10 c vector. Remember, dear student, now we find the acceleration by using derivative of what? Of velocity. After that, we find the velocity by using derivative of the displacement. Dear student, this example is very important. Why? Because we use derivative of displacement respect to time t. Why? Because the velocity v vector equals ds vector over dt. After that, we use the derivative of the velocity respect to time t to find the acceleration a. Remember, after that, we find the work. The work done equals fa. What is the a? Is acceleration, ma. What is the m? The mass. A, acceleration. We find acceleration after we find the velocity. Then we have the relation between s respect to time t. From this relation, find the velocity by using derivative ds or by using derivative of displacement respect to time t. After that, we find acceleration by using derivative the velocity respect to time t. Then find the work done. Look at the third solution. After we find a, acceleration is 10c, we find at t equals 3, then s equals 30 power 3 plus 4t equals by using 21 meter. This is displacement. We know that w equal f times s. We use 40 times 21 equals what? 840 joule. Another example. A body of mass 2 gram moved on the plane x or y under the effect of the force F vector 8I plus 4j equals a t squared plus 5 inside bracket I vector plus bt squared plus 2j vector, and r, norm r is measured on centimeter and t in second. Find the value of a and b, then calculate the work done by the force F in the interval from t equals 0 till t equals 5. Solution. We know that S equals displacement r minus r naught. What is the S? A t squared I vector plus bt squared plus tj vector. This is relation number 1. We find the velocity ds respect to derivative ds respect to time t. Then what is the derivative? 2ati plus 2bt plus 1j vector. Remember, dear student, S equals at square I plus bt square plus t inside bracket j. And the first, we find the velocity by using derivative displacement respect to time t. By using derivative, then S is v equals, or v becomes 2at inside bracket I plus 2bt plus 1j. A vector equals dv by dt. By using derivative velocity respect to time t, then a vector or acceleration vector equals to ai plus 2bj. Remember, a vector means acceleration vector, but a and b is the variable, a and b. Then we know that the force equals ma. M is mass, a is acceleration vector. By using F equals ma, what is the F? 8I plus 4j. What is the M? 2 multiply acceleration 2ai plus 2bj. Remember, dear student, we know that a acceleration 2ai plus 2bj, and we know that the vector F equals ma. By using left hand side and right hand side, 8i plus 4j equals 2 multiply 2ai plus 2bj. By using like terms, we know that 8 equals 4a. What is the value of a equals 2? After that, dear student, by substitution 4 equals 4b, then b equals 1. Therefore, S equals 2t square I plus t square plus tj. Then the work equal F scalar product S. By using scalar product, we find the work done equal 22 squared plus 40. By using t equals 0, find W1 equals 0, t equals 5, W2 equals 520. Then we find the work done, W2 minus W1 equal 520 H. Dear students, this lesson is very important in our life. The work needs the force and the displacement. Dear student, I am very happy to spend such time with you. Goodbye.